In the world of DevOps, pipelines are essential for automating the process of building, testing, and deploying applications. They ensure that code changes are integrated and delivered efficiently, reducing the risk of errors and increasing the speed of delivery. Pipelines can be defined using various tools and languages, but YAML, yet another markup language, has become a popular choice due to its simplicity and readability. YAML is a human-readable data serialization standard that is easy to write and understand. It is widely used for configuration files and in applications where data is being stored or transmitted. In the context of pipelines, YAML allows developers to define complex workflows in a clear and concise manner. This makes it easier to manage and maintain pipeline configurations, especially in large projects with multiple contributors. A YAML pipeline typically consists of stages, jobs, and steps. Stages represent major divisions of the pipeline, such as build, test, and deploy. Jobs are units of work that are executed within a stage, and steps are individual tasks within a job. Each of these elements can be defined using YAML syntax, allowing for a high degree of customization and flexibility. Stages are the top-level components of a YAML pipeline. They allow you to organize your pipeline into logical sections. For example, you might have separate stages for building your application, running tests, and deploying to production. Each stage can contain one or more jobs, and stages can be configured to run sequentially or in parallel, depending on your needs. Jobs are the building blocks of a pipeline stage. Each job represents a set of tasks that are executed together. In a YAML pipeline, jobs are defined within stages and can include various settings such as the agent pool, environment variables, and dependencies. Jobs can also be configured to run conditionally based on the outcome of previous jobs or other criteria. Steps are the individual tasks that make up a job. They can include commands to build your application, run tests, or deploy artifacts. In YAML, steps are defined within jobs and can include various settings such as display names, conditions, and timeout values. Steps can also be grouped into templates for reuse across multiple jobs or stages. Variables are a powerful feature in YAML pipelines that allow you to store and reuse values throughout your pipeline. Variables can be defined at the pipeline, stage, job, or step level, and can be referenced using the variable name syntax. This makes it easy to manage configuration settings, credentials, and other values that may change between environments or pipeline runs. YAML pipelines support conditional execution, allowing you to run jobs or steps based on specific conditions. This can be useful for scenarios such as running tests only if the build succeeds, or deploying to production only if all tests pass. Conditions can be defined using expressions that evaluate to true or false and can reference variables, job outcomes, and other pipeline data. One of the key benefits of using YAML for pipelines is the ability to create reusable templates. Templates allow you to define common pipeline components once and reuse them across multiple pipelines. This can help reduce duplication and ensure consistency across your pipelines. Templates can include stages, jobs, steps, and variables, and can be parameterized to allow for customization. YAML pipelines can be integrated with source control systems such as GitHub and Azure repos. This allows you to store your pipeline definitions alongside your code, making it easy to version and manage changes. When a change is pushed to your repository, the pipeline can be automatically triggered to build, test, and deploy your application. This integration helps ensure that your pipeline is always in sync with your code. Security and compliance are critical considerations in any pipeline. YAML pipelines support various features to help you secure your pipeline and ensure compliance with organizational policies. This includes support for secure variables, access controls, and auditing. By using these features, you can help protect sensitive information and ensure that your pipeline meets regulatory requirements. Monitoring and troubleshooting are essential for maintaining the health of your pipelines. YAML pipelines provide various tools and features to help you monitor pipeline runs, identify issues, and troubleshoot problems. This includes detailed logs, notifications, and integration with monitoring tools such as Azure Monitor. By actively monitoring your pipelines, you can quickly detect and resolve issues, ensuring that your pipeline runs smoothly. To get the most out of your YAML pipelines, it's important to follow best practices. This includes organizing your pipeline into clear and logical stages, using variables and templates to reduce duplication, and implementing security and compliance measures. Additionally, regularly reviewing and updating your pipeline configurations can help ensure that they remain efficient and effective as your project evolves. Let's look at a case study of a company that successfully implemented YAML pipelines. Company X was struggling with slow and error-prone manual deployment processes. By adopting YAML pipelines, they were able to automate their build, test, and deployment workflows, significantly reducing the time and effort required to release new features. This led to faster delivery times, improved quality, and increased customer satisfaction. In conclusion, YAML pipelines offer a powerful and flexible way to define and manage your build and release workflows. By leveraging the features and best practices discussed in this presentation, you can create efficient and reliable pipelines that help you deliver high-quality software faster. As a next step, consider exploring the documentation and tutorials for your chosen pipeline tool to deepen your understanding and start implementing YAML pipelines in your projects.